Hello. Thank you so much for joining us today. Welcome to Smartcrate's webinar on supply chain complexity. My name is Claire Tublets. I'm the CEO here at Smartcrate CRC and really pleased to be joining you today for a fantastic conversation about how the supply chain can really help us to achieve our objectives towards a net zero Australia. First of all, I'd really like to pay respects to the traditional owners on the lands on which we're all meeting today. I'm very lucky today to be joining you from the lands of the Wallumattagal people of the Darug Nation. I'm here on campus at Macquarie University, so very pleased to recognise those traditional owners as well as the ones on the lands that you're joining us here today as well. We've got three fantastic speakers for you today that represent quite a diverse cross-section of the construction supply chain. We have Chris Jones, who's the National Technical Manager at Boral. We have Peter Walker, who is the Group Head of Sustainability and Delivery at Stockland. And we have Carlo Garofali, who is the Construction Law Dispute Specialist at McCulloch Robertson Lawyers. So really glad to have them all on board. Now, obviously, we have a huge amount of diversity represented in the participants that are also joining us today. And so as part of the process, we'd actually really love to hear from you. So we're using a system called Menti.com. So while you are listening into the conversation today, we'd love you to join us over at Menti.com. So the address is right there on the screen. It's www.menti.com. And then enter the code 65335325. Jana, I'm not sure if, sorry, thank you for that, Hayley. You can just see Jana's black screen. That is not working correctly. For me, I can see the webinar screen with the details of the Menti. We'll pop this link into the description as well, just in case that's not coming up correctly for you on the screen. So that link to Menti.com and then the code as well being 65. Thanks for that, Elliot. Glad you can see that correctly. So the code is being 65335325. So if you come over and join us there, we already have a question loaded up for you, ready to go. We're going to be asking those questions as we go to really hear what are your insights on this issue of supply chain complexity. Last thing that I'll let you know before I hand over to the first of our fantastic speakers is this is an introductory session, an introductory conversation, which actually is part of a broader program of work that we're doing here at Smartcrate, running a series of facilitated workshops with industry participants to more deeply understand what some of the complexities are that relate to challenges towards net zero. And we will be holding a workshop today at 1:30 p.m, a facilitated online workshop looking into this challenge of supply chain complexity. So at the end, I'll be popping up a registration link. If you are interested in joining us, I know it's only just a couple of hours away and you might already have a full dance guide, but if you'd like to join us, we would love to have you in that workshop later on this afternoon. So without further ado, I'll hand over to Chris Jones. As I mentioned, Chris is the National Technical Manager at Boral, and he's going to chat to us about supply chain associated cementitious materials. So Chris, over to you.
Thanks very much, Claire, and welcome everyone. Thanks for joining today. So I'll just share my screen. So maybe before I kick off, just make sure, am I sharing my screen okay? It should say supply chains associated with cementitious materials and concrete.
Yep, we can see it. Yep. Thanks.
Excellent. All right. Well, my presentation will be about lower carbon cementitious materials that we are currently using to produce low carbon concrete. And these, of course, are fly ash and slag. But I will also be talking about alternate SEMs that we may be using once the supply of fly ash and slag doesn't meet demand. The reason why we use fly ash and slag is because the embodied carbon of these two products is a lot lower than GP cement. These are the Oz LCI values, and as you can see, they're much lower than GP cement. But there's also a significant difference between fly ash and slag. Based on these values, it looks like fly ash would have the greatest benefit in reducing the emissions of concrete and therefore reducing global emissions. But we need to consider the following. Firstly, we need to understand how these values are determined. One of the reasons why slag is higher in embodied carbon than fly ash is that it does require some processing. It has to be granulated and then milled into a powder. But it also gains some embodied carbon through the process of economic allocation. Economic allocation is a way of determining the embodied carbon of co-products. Co-products are two or more products that are produced from the same process. We don't want to allocate all the emissions to both products, so we allocate the emissions based on the value of each product. Fly ash is considered a waste product with no value to the producer. Power stations do sell the ash to cement suppliers, but the money they make is so low that is deemed negligible. So the embodied carbon of fly ash at the power station is zero, and only the emissions from the transport to the plant are attributed to the fly ash. Slag, however, is different. The steel manufacturers do make some money out of slag, and therefore some of the emissions from the production of the iron is attributed to the slag. This has the result of increasing the reported embodied carbon of the slag and lowering the reported embodied carbon of the steel. So we need to take this into account when comparing fly ash and slag. The other thing we need to consider is the reduction in GP cement which results from using these products. Let's look at this mix, which contains 300 kilograms of GP cement per cubic meter. We can use fly ash to reduce the cement content, but fly ash is not as potent as GP cement. So for every 1 kilogram of GP we take out, we have to add 2 kilograms of fly ash. So in this fly ash mix, we reduced the GP content by 50 kilograms and replaced it with 100 kilograms of fly ash. This has resulted in a mix with 29% fly ash, but the GP has only been reduced by 17%. I still see specifications to specify low carbon concrete by a percent of SEM, e.g. 30% SEM. But as you can see, this will not result in a 30% reduction in GP cement when using fly ash. When using slag, however, you can replace the cement on a one-for-one basis. So a 30% slag mix is likely to reduce the GP content by 30%. And we can replace much more of the cement with slag than we can with fly ash. The example on the right is a 50% slag mix, which has reduced the GP content by 50%. So the point of these last two slides is to show that to significantly reduce the GP content and the embodied carbon, slag is a much better SEM than fly ash. So let's look at the availability of these two SEMs and the effect that renewable energy will have on the supply of fly ash and the use of electric arc furnaces will have on the availability of slag. Firstly, let's look at the current availability of slag. I thought this extract from the Institute of Structural Engineers webpage in the UK gave a good insight into this issue. It states that GP is an excellent SEM that helps displace clinker demand, which I think we already knew. But then it goes on to say that it is a limited and constrained resource that is almost fully utilized globally. And the key point is the one that I've highlighted. Locally increasing GGBS use is unlikely to decrease global emissions. The production of slag will not increase simply because there is an increase in demand. An increase in demand for a fixed supply will only increase the price of the slag so that the demand and supply are balanced. And to make it worse, due to economic allocation that I mentioned earlier, a greater amount of emissions from the production of the iron will be attributed to the slag. This will reduce the reported embodied carbon of the steel, but if you're only interested in low carbon concrete, that doesn't help much. What about the future state? Electric arc furnaces will produce less emissions so long as they use renewable power. These type of furnaces will produce slag, but I don't know if they will create as much slag per ton of steel as a blast furnace. Also, their chemistry will be different, and we'll have to see if they have the same cementitious properties. Now for fly ash, and the big question is, when will the power stations close? I want to thank Craig Heydrich from the Australian, the ADAA for this slide. It shows the power stations, when the power stations are scheduled to close. It includes all power stations, even those that don't produce fly ash for concrete, such as those in Victoria that burn brown coal. But along the top, it gives the fly ash output as a percentage of 2020 production. As you can see, there's already been some changes to the schedule, with Eraring now operating until 2027, and there may be other changes depending on where we're at with supply of renewables, but there's no doubt the power stations will close, and with it, the supply of ash will be reduced. In the absence of ash, many people are considering using pond ash. Pond ash is produced by the power stations, but not supplied to the industry, and was simply dumped in ash dams like this one. To understand the challenges of using pond ash, we firstly need to understand why the ash was sent to the ash dam in the first place. In most cases, it's because of one of these. It might have been good quality ash, but there was no demand at the time. It could have been there was a holiday period or extended wet weather when cement suppliers and concrete users didn't have sufficient silos to store all the good quality ash, and therefore there was no option but to send it to the ash dam. But quite frequently it's due to quality issues. The carbon content may be too high. This is measured by loss of ignition, and the ash may be too coarse. Now, when they get sent to the ash dam, they aren't put in separate sides or locations, they're all mixed together. So trying to determine the good ash from the bad ash is pretty well impossible. So the question is whether pond ash will comply with the Australian standard. In the Australian standard AS 3582.1, there are 3 grades of fly ash. The special grade is used for high performance concrete in a similar way to silica fuel, which is not relevant for today's discussion. So that leaves grade 1 and grade 2. The main difference between them is their fineness and their carbon content. The carbon content is measured by their loss on ignition. Most concrete plants use grade 1 ash, but if for some reason we're unable to produce grade 1 ash from pond ash, we could supply the pond ash as a grade 2 ash, and it would still comply with AS 1379, which is the concrete standard. Grade 2 ash is likely to be less efficient, but it's certainly better than no ash. The barrier to grade 2 ash is that many specifications call up grade 1 ash. This extract on the bottom right is from a Transport for New South Wales specification, and it states that grade 1 ash must be used. So we may need to have some conversations with specifiers and suggest that the specification should be based on the performance of the concrete, and if we can achieve that with grade 2 ash, then it should comply. But I may be jumping the gun, and maybe we can produce grade 1 ash from pond ash. There's plenty of pond ash being used in America, and there is a company in South Australia who are planning on extracting the pond ash from the Port Augusta power station. I understand they plan to have this ash available sometime next year, so it'll be a case of watch this space. But regardless of the excess or otherwise of using pond ash, we will still need to explore alternate SCMs. In 2020, Standards Australia published a materials specification for manufactured pozzolans. It will still need to be referenced in the Australian Standard for Concrete, AS 1379, but I don't expect any objection to that. It is a performance-based spec, but it does give these examples as to the materials that could be covered. I've highlighted the ones that look most promising. The one in the middle is pond ash, which we've already discussed. So let's look at the other 2. Calcined clay is a type of clay called kaolinite, which has been heated to around 800 degrees centigrade. It calcines the clay, hence the name. It is also referred to as metakaolin. Companies in Australia are currently exploring suitable deposits of kaolinite, but so far it hasn't been produced in any significant quantities. The image on the right is a product called LC3, which is a blend of cement containing cement clinker, limestone, gypsum, and calcined clay. And they've been put together in ratios to optimize the performance of the cement. The other potential SEM that is showing some promise is lithium residue, which is a byproduct from the extraction of lithium. There's a high demand for lithium for batteries, and Western Australia has significant deposits. Tianqi are currently mining lithium in WA and producing this lithium residue, but so far haven't produced commercially available quantities for use in concrete. That paper on the right is from a durability consultancy called BCRC, which carried out testing on samples of lithium residue that looked encouraging, and the paper is available online for anyone interested in reading it. Tianqi are the first cab off the rank in Australia, but there will be other sources as well, as shown on this slide, which is also provided to me from Craig Heydrich. And that's it. Thank you for listening.
Thanks so much, Chris. That was fantastic. And really talks to the complexity that we have here and the fact that it's not just about the technical performance of some of these supplementary cementitious materials. It's a question of what is the commercial availability of these products? You know, what's the volume? How do we actually get that logistics to work? That was really fantastic. Thank you.
Okay.
So very pleased to next welcome Petey Walker, who's joining us from Stockland. Petey, over to you.
Thank you, Claire. And I agree, that was an absolutely fascinating presentation from Chris. I'm very grateful to have been able to hear it, because concrete is actually one of our biggest, pieces of the puzzle in solving for our supply chain for sustainability. But I'll talk a little bit more about that towards the end. I'm not sharing slides. I just wanted to have a little bit of a chat through supply chain complexity. I might start with who Stockland is, though. So we are one of Australia's largest diversified property groups. We create, curate and invest in retail town centres, workplaces, logistics centres, apartments, master plan communities and land lease communities. We own $15.5 billion worth of real estate assets, and we have a $40 billion development pipeline. Our purpose, a better way to live, is absolutely central to everything that we do. And in 2023, we spent around $2 billion with over 4,000 suppliers, and 70% of that total spend was within the design and construct purchasing group. So as you can imagine, plenty of complexity to deal with. So today we're talking about the intricate world of construction management, focusing particularly on the nuanced and multifaceted task of managing the supply chain within complex building projects. And at the heart of every construction project lies a complex network of stakeholders, each contributing a unique set of skills, expertise and resources. From architects and engineers through to contractors, subcontractors, suppliers and regulatory bodies, the landscape is really rich with diversity and specialisation. And this complexity is further compounded by the sheer scale and intricacy of modern day construction projects, which demand seamless coordination and collaboration across the various disciplines and hierarchies. And the supply chain, as we know, is the lifeblood of any construction project, encompassing the entire spectrum of activities involved in sourcing, procuring and delivering materials, equipment and services. And it serves as the backbone of project execution, influencing everything from cost and schedule to quality, safety, sustainability outcomes. And managing this intricate web of suppliers and vendors and subcontractors is fraught with challenges and uncertainties at every turn. But the flip side, of course, is that wherever there are challenges, there are opportunities, which we'll turn to shortly. So one of the challenges confronting construction professionals today is the growing emphasis on ESG considerations. With stakeholders increasingly prioritising sustainability, construction projects are under that mounting pressure to adopt eco-friendly practices, reduce carbon footprints and promote social responsibility. And at Stockland, we've set some very ambitious decarbonisation targets, which introduce a host of complexities and trade-offs, particularly within the realm of supply chain management. And of course, on top of decarbonisation, ensuring compliance with stringent environmental regulations and standards adds another layer of complexity to procurement processes, requiring organisations to navigate a maze of permits, certifications and audits. Similarly, social considerations such as labour practices, worker safety and community engagement further compound the challenges of managing the construction supply chain. And with growing scrutiny on issues like modern slavery, fair wages, diversity and inclusion, organisations are under increasing pressure to uphold ethical standards and social responsibility throughout their supply chains. And that entails not only vetting suppliers and subcontractors for compliance, but also actively fostering a culture of inclusivity and equity within the industry. So in light of these challenges, it becomes imperative for construction professionals to adopt a proactive and strategic approach to supply chain management, one that's grounded in collaboration, innovation and sustainability. So I'm going to share some key strategies, just four. There's more than what I'm going to share today, but I'm going to share four for you to consider and then share a couple of examples of our approach at Stockland. So the first one, and one very dear to my heart, is collaboration and partnership. This is about fostering collaborative relationships with suppliers, subcontractors and other stakeholders, and really leveraging their expertise and insights to drive innovation and efficiency within the supply chain. It's about encouraging open communication, mutual trust and shared objectives, fostering a culture of collaboration and partnership that extends beyond the traditional transactional relationships. So the second strategy is around technology and digitisation. This is embracing digital technologies and advancing analytics to enhance the transparency, visibility and efficiency within the supply chain. It's leveraging tools such as, BIM, supply chain management software and other technology to really streamline those procurement processes and mitigate risks associated with delays, disruption and discrepancies. The third is sustainability and resilience. So integrating sustainability considerations into every aspect of the supply chain, from supplier selection and material sourcing through to transportation and waste management. And it's prioritising suppliers with strong ESG credentials, promoting eco-friendly materials and practices, and implementing measures to reduce carbon emissions and environmental impact throughout the project lifecycle. And investing in building resilience within the supply chain, so anticipating and mitigating risks associated with climate change, natural disasters, and even geopolitical instability. And then the fourth strategy that I want to share is around ethical and responsible procurement. That's really about upholding ethical standards and responsible business practices throughout the supply chain, ensuring compliance with labour laws, human rights standards, ethical codes of conduct, and conducting really rigorous due diligence on suppliers and subcontractors, assessing their adherence to these social, environmental and governance criteria, and holding them accountable for any violation or breaches. So I guess that's our approach to strategic procurement. I want to give you one example. Well, I'll give you a couple of examples on how that plays out at Stockland. I mentioned before that Stockland has set some fairly ambitious decarbonisation targets. We've extended going beyond our Scope 1 and 2 emissions, which are under the direct control of Stockland, into Scope 3, which extends beyond our direct control. And why did we do that? Because over 85% of our emissions footprint is actually in that Scope 3 part of the footprint, the ones outside of our direct control. So we really needed to, step up and play our part in that space. 40% of our total footprint is actually associated with the materials we use in our developments. And the most significant contributors to that are concrete and steel. And the traditional approach, once we've made that commitment and said, right, we're going to reduce, our carbon footprint in our developments, would be to pass that through as a target to our principal contractors and pay the premium that would be passed through from those principal contractors. But instead, we're leveraging our scale and collaborating and partnering deeper into our supply chain. So great to hear from Chris from Boral, because they're one of our key partners in this. We entered into a memorandum of understanding with Boral to advance the use of lower embodied carbon concrete, providing between 35 and 55% lower embodied emissions compared to conventional options. And because of using our scale and dipping down below the traditional first tier in our supply chain, and because of the collaboration and the aligned, ESG vision that both Boral and Stockland has, we're able to do this in a really commercial manner. So it required not just the memorandum of understanding between the two parties, we then needed to work side by side to bring our first tier suppliers along on the journey to say, look, here are the rate sheets, this is the outcomes, this is the vision, this is what we're trying to achieve. And we held workshops in each state with our key suppliers and the most senior people in the key suppliers as well. And those workshops were led by both Stockland and Boral, and they've generated enormous buy-in, and it's directly contributing towards us meeting those decarbonisation targets that we've set. So that's on the lower carbon products. We're also turning our mind to steel and others. One of the other ones before I close out that I wanted to talk about is our builder partnership model that we've been moving to in certain sectors. I'm pretty sure most participants on the call will understand the disruption that the construction industry has gone through over the last few years. And we have a particular sector that is on a significant growth trajectory, and it relies on domestic builders to deliver that growth trajectory. And they have gone through a lot of pain over the last few years. We've seen insolvencies, we've seen, organisations get through, but by the skin of their teeth. These guys are incredibly important to us. We don't deliver for our customers without them. And what we reflected on was that we'd been taking the approach that we have been for 20 years or more. Here's a contract, we try to push as much risk as possible down the line, just like happens in, the major contracts as well. And we're probably applying that kind of approach. And then leave the builder to deal with all the risk. And we realised that, in today's environment, you just can't do that. You've actually got to take a new approach. So we introduced a new delivery model to drive both improved scalability, but also improve customer satisfaction across our delivery locations. And it really focuses around fewer, so less partners, but higher quality builder partners that align on our values for deep, long-lasting partnerships. And we supported that by a collaboration deed, increased consistent visibility of the performance measures, and having the appropriate governance. The builder partners that we're working with on that are really welcoming this approach, and we're looking at, how we roll that out as appropriate to other sectors. So to wrap up, I'd probably leave you with these messages. Managing the supply chain of complex building projects is a formidable task, and it is fraught with challenges and uncertainties, but it's also brimming with opportunities for innovation, collaboration, and sustainability. And by adopting a proactive and strategic approach to supply chain management, grounded in collaboration, innovation, and sustainability, I think, we can all, as construction professionals, navigate the complexities of the modern day construction industry with confidence and resilience, driving positive impact for our stakeholders and the communities alike. Thanks, Claire.
Thanks so much, Petey. That was fascinating. I loved all of your advice there, and also hearing about the MOU and the partnership that you have with Boral and the way that that's really helping you to drive those, particularly Scope 3 emission reductions. Absolutely fantastic. Thank you. Before we go over to Carlo, we're going to swap into our Menti discussion. So if everyone's had a chance to load that up, there are some questions in there already, and I can see that we've already got some answers coming through. So just a quick reminder, the way that you get here is you go to menti.com, and then the code to access this slide is 65335325. Or you can, I believe that Hugh has put a link directly into the chat as well. Our first question was, what concrete supply chain complexities or risks impact you? And I think so many of them have already bubbled out of these presentations this morning. Really fantastic to hear both from Chris on the material supply side, and then Petey talking about the complexity in managing projects and ensuring that that suppliers also have those same commitments to ESG is just phenomenal. So I really enjoyed hearing both of those. If you have some time, pop in some answers here. And just to note as well, as we go through Carlo's presentation, there will be another question that pops up at the end of this that we'll come back to as well. So please jump in here when you have a chance. Otherwise, I'm really pleased to hand over to Carlo, who's the last of our speakers, who is with McCulloch Robertson, lawyer who works in the building defect litigation space. So Carlo, over to you.
Hi, everybody, and thank you very much for this opportunity, Claire. I'll just try and share my slides. Oops. If someone can confirm that you can see my PowerPoint slide.
Yep, they're up and running.
Okay, perfect. Thank you. So part of what I want to speak will partly overlay with the previous presentation. So thank you very much, Petey, for your enlightened view of or a new pragmatic approach to overcoming the supply chain complexities that we're facing challenges with. But I wanted to just give the attendees a bit of a high-level construction lawyer's perspective and what I consider to be some legalistic impediments affecting our way forward. So I was asked to touch on what risks in the supply chain need to be identified, how does the industry perceive the risk, how are we managing the risks, and some key takeaways. So I think our challenge is what we're saying is there's obviously a widespread desire or an explicit appetite for innovation and recognising that we should be doing more to achieve our ESG objectives. But how do we balance that with the implicit aversion for risk? And when I say that, I think it involves a certain amount of courage to accept the challenge, and I commend Stockland's approach. But one thing that resonated strongly with part of what Petty was saying was that most people will try to offload as much risk as possible, and the contractual risk I see is not just meeting governance criteria for compliance with the environmental targets, but also how do you balance that with the structural integrity requirements of the specifications, or let's describe them as a wish list of innovations that a project is ostensibly intended to deliver. And particularly when you've got lawyers involved like me, they'll be trying to shed the risk and apportion liability in case things go pear-shaped. So the uptake of innovation, I think, is going to be greatly enhanced by the recognition and validation by standards and codes of compliance, but also, I guess, having those translated across specifications that are being drafted by the principals or the principals consultants, and then making sure that all of our cross-referencing and dotting I's and crossing T's satisfy our broader objective to achieve our ESG targets. So to increase the likelihood of uptake, I think that that's the number one goal. And from what Chris was talking about with the introduction of cementitious substitutes, just making sure that our codes are keeping abreast of that and our guidelines and ultimately our specifications. But what happens if there's a lag between the emerging technology and code recognition? We've kind of touched on that slightly, but I think the greatest chance of success will be if we have innovative principals who are comfortable with accommodating that risk of the emerging technology if there is some shoulder period of introduction of this innovation, as opposed to the current prevalence of the D&C contracting model, where all the risk of compliance is palmed off onto the contractor, and unless you've got an enlightened client such as Stockland who are recognising that you need to have a more collaborative approach, I would venture to say that that contractual hurdle is going to be a significant impediment moving forward. And in the event that your consultants or your contractors downstream are asked to provide warranties for fitness for purpose, then there are cases where the standards or the codes were not in lockstep with the technology that was being constructed, and if the consultant or the contractors provided a warranty for fitness of purpose, then compliance with the standard or the code may not necessarily be sufficient defense or protection from you if something does go pear-shaped and there is a problem with the innovation that's being introduced. And then another thing to think about, and this maybe affects the Stocklands of this world more so, is the warranties that you provide to subsequent purchases. So how does industry perceive risk? And I think the short answer is not very well in terms of today's presentation's objectives, namely because the industry is inherently risk averse. Everyone's trying to pass risk wherever possible, and the poor suckers down the end of the line who are accepting that risk do so sometimes begrudgingly, or sometimes knowing full well that that's the only way that they will win a project, and they're effectively gambling sometimes with winning the job, hoping that they'll make money and things don't go pear-shaped down the track, or inevitably when they're taking on inappropriate risk, then that's a recipe for asking for trouble. The current reality, I think, is contrary to the philosophical premise, namely that risk ought to be borne by the party best able to bear that risk. That sounds great in theory, and I think that makes a lot of sense at a high level to most stakeholders, but it's rare, and as I just mentioned, is, in my view, the source of most disputation between various parties, whether it's principals and contractors or downstream to subcontractors and consultants. So what's the solution? Having talk fests and webinars and education opportunities such as this is a big part of it. I think overcoming fear of the unknown or ignorance regarding particularly unproven technology, but also helping people make enlightened and informed decisions about how best to achieve our guidelines and not just pay lip service to it and say, okay, well, this is what we want, contractor go off and screw your subbies to make sure that they deliver it without making sure that something is actually deliverable and pragmatic, and you're not paying a fortune for it, and that whatever we have on our innovation wish list, I should say, is actually achievable. So I think part of our problem is that we don't have enough engineers involved in driving sophisticated procurement decisions, particularly at a government level. There's a lot of bean counters, there's a lot of lawyers, there's a lot of accountants, but not enough engineers, I think, who are better placed to steer us through these difficult challenges to make sure that we effectively arrive at our destination. I don't sound very much like a lawyer, do I? So, how are we going to manage these risks? So, the answers kind of overlaps a little bit of what I was touching on before. The industry is conditioned to pass on as much risk as possible, which I don't think is effective. So how do we manage that better? And maybe at a high level, I don't have all the answers, but when we're trying to formulate some of them, just keep these issues in mind, perhaps. So if we are, say, presented with a PPR, Principals Project Requirement, by someone other than Stockland, who's calling for a performance goal wish list, make sure that the contract terms and specifications are accurately mirrored all the way through the downstream parties. And what I'm getting at is our firm is involved with a Supreme Court matter at the moment, and I'll just call it the Chinese Whispers case study, in that specifications were modified downstream by some well-meaning person, but the end result was that the subcontractor at the end who supplied this technology did so in accordance with what he was asked to do, but it didn't meet the performance criteria of the end user or the client at the top of the food chain, and it's resulted in a 4-year Supreme Court matter that's still yet to be resolved. So there are horror stories out there if we don't get our jobs done right. And I touched on this before about fitness for purpose warranties, that consultants are particularly wary about providing these warranties. A lot of contracts are full of all these D&C warranties to make sure that everything is fit for purpose, and you'll have lawyers like myself going through specifications and codes and with fine-tooth comb finding discrepancies or departures as an excuse to apportion the liability for things that may not have gone as well as anticipated, or we haven't met the customer satisfaction criteria, for example. And another challenge, I think, is when we're introducing innovative technologies, perhaps you might be challenged with the financial viability or insolvency of startups, who has ownership of the goods, intellectual property ownership, You've got issues affecting performance securities, and I know we haven't really touched on it in great detail in terms of SCMs, but one issue that I see facing the introduction of geopolymer cements is the IP challenge about who owns a recipe for a particular geopolymer cement formula, and how do we get guarantee structural consistency for end users with various alternative supplies. So whilst we can rely on the likes of Boral, who are very prominent in the marketplace, to make sure that they're going to be delivering products that meet people's expectations and will satisfy codes, when we have this shoulder period of introduction of new material, and if the codes aren't keeping abreast with what's going on, then we're faced with other challenges that we need to be mindful of. So near the end, the key takeaways I see, making sure that we keep abreast of innovation with codes and standards and recognition, but also in terms of making it clear when we're talking about governance criteria, about making sure that we satisfy not just environmental targets, but structural integrity targets, and meeting the customer satisfaction expectations of the end users. The phrase of collaboration is something that we should all be resonating with, and I embrace the likes of Stockland for taking charge or leading the charge in this space. And enlightenment of industry, so making sure that when we are introducing these new technologies, that we are a little bit more courageous in terms of allocation of risk, and not just fully in lockstep with what our lawyers are recommending to us, to pass on as much risk as possible. If we can be more collaborative, then I think that'll be a great outcome for the industry generally. And as I said, we need more engineers, particularly in government decision-making space. If we're going to fast track the rolling out of new innovative materials, I think we need to make sure that government and our drafters of legislation and codes of compliance are keeping abreast with what everybody is needing and what is actually deliverable and achievable. If we can achieve the certainty of the Portland cement in terms of the materials that we're wanting to introduce, and still satisfying our environmental targets, then that's something that we need to be mindful of. You know, who owns ownership of the recipe for geopolymer cements if we're ending up going down that track? And then ultimately, how are we going to cope with diminishing supply of fly ash? You know, do we need more steel mills? That's maybe another question that we need to be thinking about. So thank you, and I'll stop sharing.
That was fabulous, Carlo. Thank you. And I like your comment earlier that wasn't very lawyerish of you. The fact that you then referred to, perhaps you need to share the risk a little bit more. That was brilliant. Thank you. And I think really talks to as well, just the complexities that we face here in terms of the rapid adoption of new lower carbon product technologies. We do need to see the supply chain really share the risk in the adoption of those new products if we want to achieve our 2050 targets before the time is up. So thank you so much. Thank you to all of our speakers today, Carlo, Petey, Chris. It's just been fabulous to hear from across the supply chain what some of the issues are that relate to supply chain complexity, particularly as we move down the path to meet our net zero target. If I could swap us all back over into the Menti again, because we'd really love to hear more from our audience participants, what you think. So we do have that question that's up at the moment, which is asking you, what do you think are the complexities? And we've already got some really fantastic answers here. So really talking to confidence, accelerating the low carbon concrete products and the adoption of those. I think there's a few here that really talk to that risk as well, which is what Carlo has really beautifully highlighted there. So yeah, thank you for all of those insights. Oh, thank you also, Hugh, for scrolling down. There's a lot of information that's coming in there. Yeah, that slow movement of decarbonisation is a real challenge, and also noting the benchmarking there as well, that I think that's something that we've identified at SmartCrete as well, ensuring that we have really clear definitions, clear language, common language, and really good classifications that help us understand what do we mean when we're talking about low carbon. There's been some great work that MECLA has done recently in concrete. If people haven't seen that, there's now a guide to low carbon concrete that MECLA have released, which is a fantastic start down that pathway. So thank you for all of your answers here. If we swap into our next question, we're keen to understand where the people on the line are from. So if you've still got your Menti app open, if you could pop in there and tell us, where are you from in the supply chain? So we've got some people joining us from research, which is great. Design and engineers and material concrete suppliers, fantastic. I know that we've got about 50 people on the line with us today. So yeah, really keen to understand, where do you see yourself in the supply chain? Thank you for that. And I mentioned earlier, this is a start in a much broader conversation that SmartCrete is very keen to have with you all around how we might look at the challenges and opportunities related to supply chain complexity to meet our net zero target. So we will be hosting a facilitated workshop, which again will be part of a series. The first one is this afternoon at 1:30. And so we'll pop a link in the chat if you are keen to join us to go deeper and talk about your own experiences relating to the issue of managing a supply chain. We'd really love you to join us. So I believe there is, thank you, Yana, it's popped the link into the chat. So please feel free to join us. Thank you. If we move over, we do have one more question, I believe. So we're keen to understand again, just what do you think are some of the issues, particularly when we're thinking about procuring or sourcing materials, products, services as part of the construction supply chain? What are the types of challenges that you face towards decarbonisation? So we heard Petey talking about the procurement decision making, for example, and how that needs to be driven towards ESG targets. What do you think are some of the challenges or opportunities, I suppose? And lovely to see Hempcrete there. We've got a couple of researchers in our sector that are doing some fabulous work with alternative materials, supply chains, the circular economy, etc. So great to see that. We'll give you a couple of moments to pop in some responses there. Otherwise, while you're having a chance to load your thoughts into the Menti app, can I again just very deeply thank all three of our presenters. It's been absolutely fantastic to hear from your experiences at Boral, at Stockland, at McCulloch Robertson. What are the challenges and opportunities as we work together towards net zero? So I'll ask everyone on the line, even though it's a virtual session, so a little bit hard to give a round of applause. But thank you so much for your time. Thank you for joining us. And again, please feel free to come and join us in a further conversation through the facilitated sessions that we're going to run. Or if you have ideas and you want to reach out, you can always get us at info@smartcratecrc.com.au. We would really love to hear from you more about what your thoughts are as we transition concrete to a net zero future. So thank you again for joining us.